we're going to move on to talking about how molar mass and molecular mass are different now. Basically saying that if we're calculating molar mass, we are trying to figure out the mass of something that has 1 mole in it. So we're looking at the mass of something that you can see with your eyes and that you can hold in your hand. It's on a larger scale. If we're calculating the molecular mass, we're trying to figure out the mass of 1 molecule of a compound. So this is on a very small scale. It's not something you can see, and it's a lot smaller as it were if we were doing molar mass. So we did talk a little bit about the fact that there are different units. For molecular mass, we've got AMUs, which means atomic mass unit. And this is what we're using because if we were to try and do molecular mass in grams, the number would be so small, it basically wouldn't even register. For molar mass, we use grams per mole, which means how many grams are in 1 mole. And we do this because we can register that on a gram scale, and it is a more visible substance. Something that you may have noticed was that the masses that I used for each of the elements to calculate their individual masses before adding them together were the same. And that is because AMU is equal to grams per mole. So I'm going to show you how these are equal. So I'm going to use hydrogen as our example here, and we've got that as 1 AMU. And I have found a conversion here that gets me from AMUs to grams. So I have 1 AMU equals 1.66054 times 10 to the negative 24th grams, and it is over, and this is going to equal 1 mole. So if you tried to go through and do the math for this, the number would basically not even change at all. That is how they're equal. The conversion is so tiny that it ends up being the same number. Now let's talk about what a mole is. We've been talking about how molar mass is the calculation for the weight of 1 mole of something. Well, a mole is a term that we use to describe how many atoms or molecules are in a sample of a substance. 1 mole of a substance is equal to its atomic mass or its molecular mass or its formula mass. And formula mass is something that we talk about when we're talking about compounds. We talk about molar mass and we also talk about formula mass. We kind of use those interchangeably. Carbon's atomic mass is 12. So we have 1 mole of carbon if we have 12 grams of carbon. How much is really in a mole? Well, if we're thinking about a mole of any substance, it is going to equal to 6.022 times 10 to the 23rd atoms or molecules. So if I have 1 mole of carbon, I have 12 grams. Well, inside those 12 grams, I have 6.022 times 10 to the 23rd atoms. What if I was looking at a mole of water? Well, 1 mole of water is equal to 18 grams. And then in those 18 grams of water, I have 6.022 times 10 to the 23rd molecules. Well, how did we get this 6.022 times 10 to the 23rd number? Well, this guy named Amedeo Avogadro, he is an Italian scientist from the early 19th century, and he figured out that 1 mole was equal to 6.022 times 10 to the 23rd atoms. He did some testing, and basically, after lots of number crunching, he had come up with this answer. So when we're talking about 6.022 times 10 to the 23rd, typically we call this Avogadro's number because it kind of rolls off the tongue a little bit better than 6.022 times 10 to the 23rd. So if I'm ever referring to Avogadro's number, that is what I'm talking about. Now we are going to take some time to learn how to calculate moles, just because if for some reason you are given a sample that is larger or smaller than its molar mass, then this way you can figure out how many moles you were actually given if you are asked. So to figure out how many moles, we have to take the mass that we're given divided by its molar mass. Well, we've learned how to calculate molar mass, and my example here says how many moles are in an 80-gram sample of water. We know that our water formula is H2O. We know that we need to figure out the molar mass of this water molecule, so let's go ahead and do that. For hydrogen, we have 2 moles. Oxygen, we have 1 mole. Hydrogen's mass is 1. And oxygen's mass is 16. So let's do the math on that. 2 times 1 is 2. 1 times 16 is 16. Now add those together, and that gives me 18 grams per mole. I left the mole on this time because that is the unit that we need to get to. Now, in order to calculate how many moles I have, I need to take the mass I was given, which is 80 grams, divided by my molecular mass, which is 18. And that gives me a mass of, moles. That gives me 4.44 moles of water. All right. There is a little wrench to play with this. Some of the elements that we have on our periodic table exist as molecules, or what we like to call them is diatoms. This, if you're going to use this as your calculation, you need to use the molecular mass for this rather than its atomic mass. So some examples of a diatom would be like hydrogen, nitrogen, and oxygen. Typically you'll see them written with an H2 or an N2 or an O2, and that's because in the natural world, in their natural environments, they do not exist on their own. They're either bonded to another atom of themselves or they make up a whole different compound. So for those, we would just calculate the molar mass of it, and you know how to do that. So the molar mass for this one we would use is 2 grams per mole. All right. Now for compounds, the molar mass is the sum of the atomic mass for each of the atoms in the formula. We know how to do this. Let's do an example of calculating moles. In this question, I said that we have 102 grams of aluminum. How many moles do we have? Well, our steps are to take the mass that we're given, which is 102, and divide it by the molecular mass or the molar mass. So the mass of this is 26.9. Let's round that up to 27. And now take 102 divided by 27. This should give you 3.78 moles of aluminum. Let's try another. So we have 10 grams of barium, and I want to know how many moles we have. Start with what we were given, 10 grams. Use the molar mass or molecular mass which is 137. And do the math. Take 10 divided by 137, and that gives you 0.07 moles of barium. So something you may have noticed is if our mass given to us is lower than our molecular mass, our moles are going to be below 1. But if our molecular mass is below our given mass, it will be above 1. So that is a great way to check yourself to see if your answer is correct. Just take a look at the mass you're given, take a look at your molecular mass, and see if it's above or below and about where your number should be, if it should be above 1 or below 1. So just to recap, to calculate molecular mass, you figure out the mass of each of the elements first and then add them together. 1 mole is equal to the atomic mass of something. To calculate moles, you need to take the mass provided and divide it by the molar mass. And to calculate the molar mass, you have to figure out the mass of each element first and then add the masses together. So this brings us to the end of this lesson. I hope you have a great day and good luck calculating.